Hello, so in this video I'm going to be teaching you how to find an integral by integrating by parts. So if you look here, you can see I've got the integral I want to find here, and the integration by parts formula here. I'll talk you through how this works. So I start with two expressions, u and v. I want to find the integral of u dv. Well, dv is governed by the formula that dv is the derivative of v, dv over dx, times dx. And you can almost think of the dx as cancelling. Same applies to the du here. So when you've had a look at that formula, let's go on. So here, I've got an integral, two things multiplied together. Okay, well, I know that with a bit of forethought, I can take u and v to be equal to sine x. Because you've got u is sine x, so you've got the sine x there, and the derivative of v, derivative of sine x, is cos x dx, cos x dx. Okay, so now this will be, so I've got integral sine of x cos of x dx equals sine x times sine x, this term, or sine squared of x, minus integral v of sine x du, where u is sine x. So that just comes out as cos x dx, for the same reason as y dv is cos x dx, because they're the same. So it's cos x dx. So you look here, you can see I've actually got the same integral on both sides. Now you may be wondering, what should we do here? This doesn't seem right. But it's fine. So all we need to do is add this, take down to this side. So I have 2 integral sine of x cos of x dx equals sine squared of x, and then dividing it through by 2 gives you integral sine of x cos of x dx equals 1/2 sine, if you can see that, sine squared of x. Now you may be wondering, where's the plus c here? Now the thing about the integration by parts method is when you do it under normal circumstances, the plus c is accounted for with this integral term. However here, this integral term was just added to the other side, so there's no plus c. So in the last step, don't forget, in a case like this, you have to add plus c. Okay, so that was how to integrate by parts. Thank you.